Hello and welcome to a brand new episode of the Data Science Daily series. And I'm Anant. I'm very excited to have you here back again. Today, our main agenda is going to be talking about functions in Python. So, with introducing functions in Python, we are going to introduce the paradigm of functional programming in Python. So, for that, the base is understanding how to write functions, what are functions, how do you call them, how do you design functions, and what are the different properties and parameters of functions. So, we will go into functions in a lot of depth. First, we will start with the basics of functions, that is today. Then we will go to some more complex topics in the next few parts. So this entire topic of functions is broken down into chunks, and this is a multi-part series. So make sure you're watching all the parts as and when they are released. Without further ado, let's get started. All right. I hope you can see. And with this, we will start with the functions in Python Jupyter Notebook, which is basically how we are going to cover this topic today. If you're not familiar with Jupyter Notebooks, if you don't know what it is and how do you get this environment up and running, make sure you're watching the video where I'm explaining how to install Python and also talking about some of the basics of Python before coming here, right? If you already know and if you have already launched it, well and good, just follow along. So the basics of functions in Python. Firstly, let's understand what are functions. Basically, functions are a set of instructions that you're giving in a very structured manner or step-by-step manner. And at the end of those steps, you want a certain kind of an output, right? A certain completion of a logic, basically. So each instruction gives and executes one step, but at the end of it, you have the complete solution, basically. So functions are a set of instructions that you can combine together for better execution and better readability. It basically executes one kind of a function itself, right? The functions serve a particular purpose. That's why they are written and they are put in bite-sized pieces of code, right? Now, why are these useful? The first thing is you can define a function once and then you can call it multiple times with different inputs, saving time and effort and also saving time to write the line of code and modify it slightly, right? Each time you have a different input. You don't really need to do that. So code reusability is the first one. Second one is functions break down complex programs into smaller self-contained units. Basically, it's helping you organize the code better and better readability for any new person who's coming in, or even for yourself when a few months down the line, you're looking at your code and you're wondering, okay, what does this really do, right? If it is written in a function, it has a doc string. We will shortly discuss what doc strings are, right? It will make it very easy for you to understand and recap. Third one, well-defined functions with doc strings, right? This is what we just talked about. Doc strings are basically brief explanations of the function's purpose, right? So well-defined functions with doc strings make code easier to modify and also debug, right? So that means it helps in the maintainability of the code. And the fourth one, functions are isolated units of code, making them ideal for unit testing, right? Testing is very important whenever you're writing code to make sure that it is bug-free, right? You can test individual functions with specific inputs to ensure that the functions are producing expected outputs. And this becomes very, very important when you're writing complex functions, right? Your functions are doing not straightforward operations, but they are doing complex data science operations, right? Let's say you're writing a machine learning model training function, or let's say a cross-validation function, right? You can write functions for every single thing in the entire data science pre-processing, machine learning building, post-processing, and so on. So code reliability is the fourth one. So these are the main benefits of using functions. Now, how are functions different from methods? Remember, we were using these terms interchangeably in the past few sessions where we called certain functions, we called certain functions methods. So what is really the difference? Simply put, all methods are functions, but all functions are not methods. The reason is that methods only apply to objects, right? So we will talk about what objects are, what are classes, but basically an object is an instantiation of a class, right? And that class basically has some defined functions within its own definition. So when you're defining a class, you're actually also defining certain functions that apply to that class or that will apply to an object of that class, right? So if you're writing such functions that apply to that class or to that object, basically there needs to be an instance of that object, and the function can only apply to that instance of the object, right? So that's when it is called a method. Any such function which applies to an object and object only is called a method. But any function which is can be standalone, right? It is not dependent or tied in to a particular object. It is called a function. So a function is a larger superset, and then methods are one kind of functions which are very specifically applied to certain objects. So this is how functions are different from methods, right? You can call methods functions, but you cannot call all functions methods, right? So keep this in mind. Now let's go into the technicalities and hands-on on defining functions. First, we will understand how do you define functions. So we will go over the syntax of this. So the def keyword marks the beginning of a function definition, right? And this is what the syntax looks like. Def, basically define for short. You can give a function name to the function. It can be any function underscore name, right? Any name you can give. This is up to you. And you can give certain parameters as the basically inside that function name that you have just given. So function name brackets parameters. This is how the function is getting defined. The function has a name, and the function also has certain parameters, right? You put a colon mark after it, and then you indent from the next line onwards to make sure that Python understands that whatever is coming as indented code after that is within this definition of a function. So the first line here is a function docstring. This is optional, right? And this is in quotation marks, which is basically it's a comment kind of, right? But it's not really a comment. It's a kind of a comment. It's very strictly speaking, it's a docstring. And this is optional, but recommended for code readability. Then after that, you have the function body, which is basically a set of instructions to execute. And then at the end, you can have a return statement, which is very specific to functions. It can return some output value, right? And this is again optional, right? You can choose to have the return statement, or you can choose to omit it, right? For example, if you just want to print something as part of that function, you can choose to omit the return statement. Return statement is useful when you actually want to return the value as an output of that function getting called, and to that value you want to keep doing certain operations on top of it. So that's when you return the value, which is an outcome of that function, that you want to reference that value somewhere else. But you can also have things like just print it, and in that case you don't need to return anything, right, as part of that function. Okay, let's break this down again. So def initiates the function definition. Function underscore name is a descriptive name that identifies the function, right? It should follow variable naming conventions, right? Like it cannot start with symbols and so on. Parameters are optional. Functions can have parameters. Function can choose to not have parameters, right? So parameters are optional. These are comma separated list of variables that accept values when the function is called, right? These serve as placeholders for the data you pass to the function. It will become clearer when we talk about examples. Docstring is a brief explanation of the function's purpose and usage, enclosed in triple quotes. Function body is the indented block of code, and then return is an optional statement that specifies the value the function returns to the calling code. So this is how we define functions. Now let's come to how do you call the function. You can simply call the function by giving the function name and passing in certain arguments to that function, right? Now, what are arguments and what are parameters? We just talked that, function has certain parameters. And now here we are saying that passing certain arguments to that function. So arguments are basically the values that you're passing in for the parameters, right? So function name brackets arguments. Arguments means, right, there can be different kinds of arguments, which we'll shortly see. There can be required arguments, there can be keyword arguments, and so on. But arguments basically means you are passing in certain values. So function name here is a name, and arguments is a comma separated list of values that are passed to the function's parameters. So whenever you're passing a comma separated list in that order, the function understands that in that order, these arguments are the values for the parameters in the same order, right? So if you have parameters like A, B, C defined in that order, and you have arguments you're giving 1 to 3, so A will become 1, B will become 2, C will become 3, right? Okay. So the number and order of arguments must match the parameters in the function definition, right? As long as all are required arguments. If you have certain default arguments, you don't need to define every parameter separately, right? Or every argument separately. Okay, so this is how you call functions. And this has so long been a very theoretical introduction to functions, right? But as we all know, understanding how to write functions comes with practice and with examples. So the first example, area calculator function. Write a function that can calculate the area of a rectangle given the length and the width, right? So let's say we want to calculate the area of 10 rectangles that have dimensions of the form n comma n plus 1, where n ranges from 1 to 10, right? So in the first rectangle, basically the length will be 2, the width will be 1. So 1 comma 2. In the second rectangle, it will basically be 2 comma 3. Width will be 2, length will be 3. And so on. You have 10 rectangles. The last one will be 10 as width, 11 as length. Now you want to calculate the area of all of these 10 rectangles and you want to print it. Without using a function, how would you do this? You can simply call a for loop, right? Because there is a certain pattern through this question, that is n comma n plus 1. So you can always keep an iterable for n, which is I, right? For I in range 1 comma 11, where I will range from 1 to 10, because remember 11 will not be called. Length you can define as I plus 1, right? Which is n plus 1 here. Width will be I, right? And then area will simply be length multiplied by width. And you can print that the area of the rectangle number is that particular output, right? So if you do this, you will see the area of rectangle 1 is 2, rectangle 2 is 6, and so on. You're getting this output. Now, how do you do this in a better and more readable manner using a function, right? Now, one more interesting thing is in a function, you can define the name of the function. So the name actually tells you in a manner what the function is supposed to do, and the docstring actually clarifies it even more, right? So with using functions, step one is defining the function. Def, right? This is how you define the function. Calculate underscore area. And then in the brackets, I'm giving length comma width. So length comma width, length and width are the two parameters of this function whose name is calculate underscore area. And then a colon mark. And then remember, I'm indenting this, right? This is indented. So this is all part of the function, which is calculate underscore area. The first line here is calculates the area of the rectangle. That is a docstring within triple quotes. And then we are saying area is equal to length multiplied by width, return the area. So I run this. Now my function is ready, right? So if I just do calculate underscore area, and here I open the parentheses and I press shift tab twice, you will see that the signature is given and the docstring is also given, right? So this is an inbuilt feature of Jupyter Notebook. Calculates the area of a rectangle and the type is called function, right? So Python Jupyter Notebook has actually stored this. Now, how do you actually call this function? We'll use the again for loop. For I in range 1 comma 11, rectangle underscore area is equal to calculate underscore area I plus 1 comma I, right? Why I plus 1 comma I? Because I plus 1 is the length, right? The first parameter is the length. So I plus 1 argument will be the parameter length's value, length parameter's value. And I argument will be the width parameter's value, right? And when you call this function, it will return a value, which is the area, right? So it is returning the area, which we are assigning to a new variable called rectangle underscore area, right? And once you have defined this, you're just then printing it, right? And it is giving you the same output. So you can see how you're structured the code. It is much more readable, right? It is much more understandable, and you're calling the same function to perform that area calculation underneath the hood, right? So doing this makes the code very readable, very modular, and it is the best practice as well. Now, let's see an example where you don't need to return or you don't want to return anything. So you can just use the print statement in function. Why can we do that? Because in this example, all we want to do is we want to print the area of the 10 rectangles, right? So if we can modify our function accordingly that it just prints the area, you don't really need to return anything from that function, right? Actually, think about this. In this for loop, which we are currently using, how do you actually, combine these two lines? That is, you don't want to have a rectangle underscore area variable separately. You just want to execute the function, and the function itself will print something onto the console, right? Okay. So I'm creating a new function because this function will now calculate the area and also print the area. So I'm defining calculate and print area function. Now it is taking three parameters: length, width, and the I, which is the rectangle number, right? And I'm defining the docstring, calculates and prints the area of rectangle. Area is equal to length multiplied by width. This is same as before, but now instead of returning, I'm printing the area, right? So print the area of rectangle I is area. So if I do this, this function is now ready to use. And I can simply call the for loop, which is one line of code within it, right? So for I in range 1, 11, calculate and print area, I plus 1, right? This is the length. So I, when it is 1, length is 2. Second argument is I again, which is 1, which will take the value of 1 first. So that is the width. So length is 2, width is 1 for the first rectangle. And I is again 1. So this is telling us that the rectangle number is 1, right? Because remember, this I, which is being defined inside the function, this is different from the I which is coming in here. And we will see this when we discuss local variables versus global variables in one of the next sessions on functions, right? But just keep that in mind. Let me actually change this to num, right? So that it's much better. Okay. So this I here is the rectangle number. So this I will take will be passed to this parameter called num. And you can see that the areas have been printed, right? Cool, right? Okay. Now, one thing to note here is, since you're not returning anything, what is the type of that object that is getting returned by default from that function? So what if I do rectangle underscore area is equal to calculate and print area 1, 2, test. So 1 will be, actually it should be 2, 1, test, because the length is 2, width is 1, and you're testing it. The area of rectangle test is 2. So it will print it, but it is still getting assigned to a variable called rectangle underscore area. And now if you do the type of rectangle underscore area, you will see it's a none type. So function is actually not returning anything. It's returning a none object, right? Because there is no return statement. So something to understand and keep note of. All right. So now we have discussed how to define functions, why they are useful, and also we have seen a case where you don't need to use a return statement at all, right? Now the second variation is, if let's say you want to have default arguments. Let's say you want to consider a rectangle by default that's of size 100, 2 if nothing is specified about the rectangle's dimensions, right? So you want to also include default arguments. What if the person does not actually give you these arguments, which I've highlighted here, right? And you still want the function to return something. How can you do that? What you can do is, while defining the function itself, so you define calculate and print area, but when you're defining it, you assign the value to that parameter inside the function definition. So length is equal to 100, width is equal to 2, I is equal to default, right? What this does is, it does not fix length as 100 always. If the user is not passing in any value or any argument, right, then length will take the value of 100. If the user is not passing any value for width, then only the value of width will be 2 by default. And similarly for I, right? Let's see how this works. So define calculate and print area. So this calculates and prints the area of a rectangle. Area is equal to length into width. Print, again, the normal print statement like we saw earlier. And you run this. Now, if you run this and you give all the arguments, basically, the output will be exactly same as before, right? So this is the output, and this was the output earlier. So it's exactly the same. Nothing has changed. But what has changed is, right? So firstly note, just again, quick reminder, default arguments of the function are not called when there is a defined value for the parameters or when there are arguments for the parameters. However, when nothing is specified, then the default arguments are automatically passed in. If I now call calculate and print area and give it an empty bracket, what will happen, right? It will still return 200 because 100 multiplied by 2 is the 200 is the area of the rectangle, and I will be default. So it will print area of rectangle default is 200. Right? Now I've used the same function name, so calculate and print area, which is also what I was using earlier. But now that new function has overwritten the older function. Right? So let me actually run the older function again and just show you. If I simply do this with the older function, it will give you a type error. It is missing 3 required positional arguments. So these are all required arguments, right? This throws an error. This will throw an error, right? And let me actually change with default so that it's clear that this is a different function altogether. All right. Now that we have understood this, one additional thing to keep in mind is that non-default parameters should always come before the default parameters, right? So wherever you're defining the default arguments as such, they should always come after, and the non-default should always come before. For example, let me do this. Define calculate and print area with default. Length is 100, width is 2, and then I'm giving a non-default parameter at the end, which is I. And when I try to actually create this function, it will give me an error. Non-default argument follows the default argument in this case, so it is a syntax error. You cannot do this. Similarly, I'm just changing the name of the function in each case, right? This will also not work. Where length is 100, width, the middle parameter has no value by default, and the last one has a default value. This will also not work. However, this one will work, where length is the first non-default parameter, and the last 2 parameters actually have default values. So this will work. This is the right syntax to follow. So always remember, first all the non-default parameters should occur, then only the default arguments or parameters should occur when you're defining the function. Else it will be a syntax error. Now if I do this, right, and see what is happening now is I've defined this function, but I'm giving it only one parameter now. Why? Because it requires one parameter. If I run this, now this requires one argument at all times, because there is one non-default parameter. It will give you a type error because length, there is no value by default, right? It will give you an error. How you can do it is, if you just pass in one argument, which is 100, it will automatically assign that to length, and it will print 100 multiplied by 2 is 200, and I is default. So the area of rectangle default is 200. If you give 100 comma, let's say 5, now length and width have been given, right, in the same order. I will be default. So it will give area of rectangle default is 500. 100 multiplied by 5, which is length multiplied by width. So I hope this is very clear. And lastly, you can also switch around. You can also switch around the order of the parameters if you use the keyword arguments, or you name the arguments that you're passing in. So here, right now, what I did is I just passed in the value, which is 100. And the second example, I passed in 100 comma 5. But I expected it to automatically understand that 100 is the first one, so it should be length. Second one is 5, so it should be width, because that's the way I've defined the function. Now, what if I want to interchange and I don't really remember what is the order of the parameters that are being defined? So I can just call the parameter name and assign it the value. So here, in the last case, calculate and print area with default, what I'm doing is I'm defining width is equal to 2, and then length is equal to 100. Or let me take width is equal to 12. And it will take I as default, right? So you can see that because you have defined length, right, and you have defined width, it is all well and good, right? And it is able to print that. And I can do it in any order. I can make I as new test, and it will still work, right? I've completely shifted the order of the parameters. So I hope this is very, very clear. If you have any questions, if you have any doubts, make sure you're going back and watching the video, understanding each step, because this is the basic fundamental building block of what we will discuss next, right? So we will go into more advanced and complex topics like, variable arguments. We'll talk about global and local variables, what's the difference between them. We'll talk about lambda functions. We'll talk about the main function. We'll talk about functions like map, filter, reduce, and a lot of more concepts. Just a quick recap what we discussed today. We discussed the basics of functions in Python. We defined how to actually define a function. How do you call it? What does the return statement do? What happens if you don't have a return statement, right? In what instances can that happen? Then we talked about default arguments and what are some of the syntax related concepts regarding default arguments. All right, this is all for today. Hope you liked the session. If you did, please make sure you're liking and also hitting the subscribe button, as well as hitting the bell icon so that you're notified of any subsequent YouTube live sessions. All right, I will see you tomorrow.